The following is a tutorial on how to write a Java program in Eclipse, which can use the compare to method in order to organize strings of text into lexicographic order. This video presupposes that the viewer is already proficient in basic Java techniques such as creating classes, importing tools, and creating methods. Before writing the program, it is important to understand lexicographic order in the context of strings. Lexicographic order works similarly to the ordering you might find in a dictionary. There are also 4 additional rules aside from the rules which govern the ordination of words one might find in an average dictionary. The first rule is that uppercase letters always come before lowercase letters. The second rule is that space characters, that the space character goes before any printable character. The third rule is that numbers come before letters. In the case of multiple strings which start with numbers, lexicographical order puts strings with smaller numbers in the leftmost character slot before strings with larger numbers in the leftmost character slot. The fourth rule has to do with punctuation and is beyond the scope of this video. I will use a program I wrote before the start of this video to demonstrate lexicographic order. This program that I've written is designed to do exactly what the program we're about to write will do. It'll take three string values and order them according to lexicographic order. Let's enter 3 strings right now. To demonstrate just the basics of lexicographic order, I will enter the word contrapposto, which is an art term, the word contrapposta, which is a made-up term, and contra, which I think is just a root that means against, whatever. The point, it'll demonstrate lexicographic order very well. As you can see, when we entered in these words, contra was first, because even though it has the exact same letters as the other 3 entrants, because it terminates before the other 2, it's listed first. In the same way the dictionary will have the word car before the word cart. Next was contrapposta, because as we know with lexicographic order, the method is to run through each letter and compare them to the letters of the other entrants. And as soon as there's a letter that goes before another, that word is placed first. So contrapposta, because of the a at the end, goes just before contrapposto, and contrapposto is third, of course. That demonstrates the basics. Just to demonstrate how capitals work in the system, we're going to enter aardvark with the capital A at the beginning of the, or at the second letter. We're then going to enter ard. Here, let's do this. Aardvark. And finally, zebra. Alright. As you can see, zebra came first because even though it starts with a Z, the Z is capital, and capital letters always go before lowercase letters. Yeah, it's the only word we entered that started with a capital letter. Next came aardvark with a capital A in the second letter, even though, what happened is the program went through and said, all right, this one's lowercase, but oh, these both start with A, but this one starts with a capital A. So aardvark with a capital A is going to go next. And finally, aardvark with a weird, awkward capital R goes last, because even though it has a capital, it's in the third letter, so these ones came before it. So that's how capital letters work with lexicographic order. let's just look at how the space rule works. We'll enter zebra with a space and then a lowercase z, and then aardvark. And as you can see, the first one is zebra with a space and a lowercase z because the space in the beginning of the word ensures that it'll definitely go first. Next will come zebra with a capital Z because of the capital rule. Capitals always come before lowercase. And finally, we'll have aardvark, even though it starts with an A, because it doesn't have a space or any capital letters. It's going to be last. All right. Just one last one to illustrate the number with rules. The rule with numbers, that is. We're going to enter 2 aardvarks, 1,000 aardvarks, and aardvark with a capital A. And what we get is 1,000 aardvarks comes first, even though it's a bigger number when taken as a whole, and it has no capitals, because the leftmost number is smaller than any others. It's going to go first. 2 aardvarks is going to go second because, again, its leftmost number is bigger than 1, but because it has a number, it's going to go before any words that don't have a number, at the beginning. And finally, aardvark here at the very end is third. So those are the rules in terms of lexicographic order. It's time to get into the actual program itself. Let's go ahead and open our file. The file I had preset for. Yeah, there it is. Here we go. All right. So let's get rid of that. Okay, here we go. So now let's get into the actual programming itself. Here we have our class. First thing we're going to want to do is import a scanner. So we're going to import java.util.scanner. All right. So that will allow us to, forgot the semicolon there. Yeah, there we go. That'll allow us to enter in strings to be ordered. All right. Next, we should probably make an object for our scanner. So I'm going to go ahead and say scanner, and then I'm going to name this object instance because I'm uncreative, and instance is the first thing that came to mind. Instance equals new scanner. System.in. All right, we have our scanner. Excellent. Next, let's declare our string variables. We're going to have 3 for this program because we're just going to be ordering 3. We're going to be ordering 3 string variables. So string first, string second, and string third. All right, we have our variables there. Let's see. Now to initialize these variables with the user input, let's go ahead and type in the following. All right. Let's go ahead and type first equals instance dot next line. All right. And then we'll say second equals instance dot next line. And third equals instance next line. All right, excellent. So just a quick recap. We've imported our scanner. We've given our scanner an object. We've declared our variables, and now this set of code here will allow us to initialize our variables with the input that the user gives. All right. So when the user types in their first word, it'll initialize this first variable. The second word they type in will initialize the second variable, and the third word they type in will initialize the third variable. Let's keep on going. Now it's time to get into the actual meat of the program. We're going to use the compare to method and if-then statements, basically. If-then statements check to see if a certain criteria is met, and if that criteria is met, then the program will do a specific task we assign to it. Just to show you what the compare to method is like, here we go. Let's go ahead and start. We're going to say if first compare to, then second. All right. So the way this program works is, here with this if-then statement, we're starting off with our if. That's how it knows it's an if-then statement. And here in the parentheses, what we're doing is we're giving the condition, what it's going to look out for. And then, depending on whether that condition is met, if it is met, then it will do all the stuff here in these curly brackets. But let's finish our condition. What we bring here is first dot compare to, and then in parentheses we put second. What this compare to method does in relation to strings is it takes the string variable you have here. So in this case we have first, and it says, all right, I'm going to take the variable that was initialized called first, and then I'm going to look at it in relation to the variable called second. And what it'll do is, if it sees that first comes before second in lexicographic order, then it will give first a negative value, which means if we type a little something like this at the end of it, if first compared to second is less than 0, in other words, if the first string comes before or is negative in relation to the second variable, then we get to type something like system dot out dot print line, right? We're going to type something to the effect of, one second, I'm getting a little error. Let me just fix that. Oh well, I'll deal with that error later. System out print line, first getting a little sloppy. There we go. First comes before, and then plus second. All right. So let's go ahead and quickly just double check to make sure that all this checks out. I'm getting a little error. All right, I should probably do this. Yeah, there we go. Excellent. So far what we have is a scanner that will get 3 strings, keep those 3 strings, and right now all we have a line for is a line that will take the first string, compare it to the second. If the first string goes before the second string, it'll give it a negative value, and if it does give it that negative value, if it is less than 0, then the computer will print out first, our first string comes before, and then whatever our second string is. So here we go. We're going to run this program right now. We're going to enter 3 strings, and remember, we just want to test if this works. We just want to have the first string come before the second. So the first string can be alpha, the second string can be beta, And the third string can be nonsense because we haven't even accounted for the third string. And if we enter it, we see alpha comes before beta. Now, if we run this again and change up the order, you'll notice, like if we say beta, alpha, and then gamma, whatever, it doesn't matter, then you'll see when we enter it, nothing happens. That's because the computer hasn't been given any instructions for how to deal with circumstances in which the second string comes before the first string lexicographically. So to save us a bit of time, what I'm going to do is I'm going to erase this and just oh boy, bother, that is something. And just copy this stuff all here from the program that I wrote before this video. And I'm going to paste it. And I'm going to explain each one of these lines. These lines will count for every possible scenario. Now, if you think about it, there are 13 possible scenarios. The first scenario is that the first string comes before the second lexicographically, and the second comes before the third string lexicographically. Right? The second scenario is that the first comes before the third, and the third comes before the second. The third scenario is that the second comes before the first, and the first comes before the third. The fourth is that the second comes before the third, and the third comes before the first. The fifth scenario is that the third comes before the first, and the first comes before the second. The sixth is that the third string that we enter comes before the second, and the second string that we enter comes before the first. The seventh is that the first and second are the exact same word, because, I don't know, our user is being difficult or something and entered the same word twice. And then those two, which are the same, come before the third. The third come before the first and second because the user entered the first and second words as the same word, but they come after the third word that was entered lexicographically. The second and the third are the same, and they come before the first. The first comes before the second and the third, which are the same. The first and the third, which are the same, come before the second. And the second string comes before the first and the third string, which are the same. Oh, and of course, the final possibility is that we have an annoying user who enters three words that are exactly the same, which is this: the first, the second, and the third. There's no order amongst them because they're all the same. So let's see how we can represent that here. All right. So in line 14 here, what we did is we used the compare to method. We said if the first string entered comes before the second string, and the first string comes before the third string, and the second string comes before the third, then what will happen is that'll mean that the first string, because it comes before the second and the third, will be first, absolutely. And because the second comes before the third, the second will be the second string. So our scenario, the thing that'll print is first, second is second, and third is third. All right. And that accounts for this scenario right here, this one. But let's look at the other ones. Here we have, if the first is smaller than the second and the first is smaller than the third, once again, first will be first. But in this case, we switched around. If when you compare the second and the third, the value is greater than 0, that means that this is positive, then third will go second, and second will go third, which we reflected here. System out print line, first is first, third is second, and second is third, which accounts for this possibility right here. Hopefully you guys get the basic idea. I'm not going to run through all of those lines, but I will skip to the possibility where some of them are the same value. So let's look at that. Here we have if first compared to the second is equal to 0, that is, if the first and second string are equal, and the third comes before the first, it stands to reason that if the third comes, or I'm sorry, if the third comes after the first, if the third comes after the first, it stands to reason the third comes after the second. Normally, we'd have to find some way to compare the first and the second, but the first and the second are the same here, so there's no need to order them any differently. If the first and the second are the same and they come before the third, then it'll print out first is first and third is second. We didn't have to put in the second string variable because first is the same, the first variable is the same as the second string variable. We do that for all 6 of those possibilities. As we see here, there are 6 of the possibilities where where the variables are equal. The final possibility is that they're all equal. And because we've exhausted every other possibility, we don't even need an else-if statement. We could just use an else statement. An else statement will encompass any possibility that doesn't fall into these, and so it doesn't need an if. It's not looking out for a condition. The only condition it's looking out for is these other conditions not being met. So we don't need conditions for it to be met. If it's none of these, then we'll just have the system print line, quit wasting my time, because that means that the user entered 3 words that are exactly the same. There's no need to order that. The user is just being annoying and difficult. Let's run this program and see what happens, okay? So here we go. Here we go. Go is first, capital G. Here is second because it's got a capital H. And we is third. It's lowercase and it's got a W. It seems to work. Let's make sure it works where some of the values are the same. Here, here, and alpha. Alpha is first and here is second. All right. And lastly, let's just make sure that if we're being a ponce and enter 3 words that are the same, like ponce, ponce, ponce. I have some friends who would do that. The system says quit wasting my time. All right. So that is how you create a program that in Java in Eclipse, a Java program in Eclipse, I should say, that orders 3 strings into lexicographic order. This presentation was put together by Group 5. Happy programming.